Bismillahirrahmanirrahim. Welcome back, students. So today we are on the lecture 16 of the Programming Fundamentals course. Today we are going to discuss a very important topic that's called recursion. So recursion is everywhere. We see many types of example in our daily life. So today we are going to see how to solve some problem of recursion using C++ language. So with that, let me go to what we are going to cover in today's topic. So we are going to see what is recursion and what is a recursive function. So recursion is a phenomenon that is occurring again and again, but with different type of data. So like you can see, you can make a circle, then you can make another smaller circle, then you can make another smaller circle. So that is called this phenomena is called recursion. So I can say that this is our one circle, and I am drawing another circle inside it and another circle, and this goes on and on. So this, I mean, we are doing one job again and again, but we have different data. What does that mean? We manipulate or we operate on different type of data, and the function remains same. So this is what recursion is. And a recursive function um, is a function that calls itself. So that could be strange for you, but yes, we have this functionality where a function is calling its own self. So, and it is calling again and again until a certain condition is met. So we are going to see how a function calls itself. So once again, the process in which a function calls itself is known as recursion, and the corresponding function is called the recursive function. So the process in which a function calls itself, so a function is calling itself, so this is called recursion. And the corresponding function, so that recursive function, that function is called a recursive function. Okay, so with that, let us discuss an example. The popular example to understand the recursion is a factorial function. Now, what is a factorial function? Factorial function is f of n, where we multiply n with f of n minus 1. And I mean, this f of n minus 1 became another function which goes on and on until we reach a base condition. So what is the base condition? If n is less than or equal to 1, then f of n is equal to 1. So this is our base condition. So when this base condition is met, we do not make a function do not make a call to itself. Don't you people worry about what does that mean. We are going to discuss what is a base condition and why it is important in the recursive function. So here is an example of a factorial function where we have f of n, and how we find a factorial of n. So we multiply n with n minus 1, and then we move on and on until the base condition, until n is equal to 1 is met. So let's say we want to find out the factorial of 5, which means n is equal to 5. So how we are going to see this example in recursion? So f of 5 is equal to 5 multiplied by f of 5 minus 1, which is in fact equal to f multiplied by f of 4. So this now becomes an independent function. So what we do, we repeat this process. We write 5 as it is, and then we said 4 multiplied by, so n multiplied by, and here is 4 minus 1. So this is again another independent function. So what we do, we like move on, we multiply 5 with 4, which is 20, multiplied by f of 3. Now f of 3 is 3 multiplied by f of 3 minus 1. We are finding a factorial. Okay, so 20 multiplied by 3 is 60, and then f of 3 minus 1 is f of 2. And then we move on, and what we do, we multiplied 60 with f of 2, which is 2 multiplied by f of 2 minus 1. The result is 120 multiplied by f of 1. Base condition is met, therefore uh, we further like go and we said that f of 1 minus 1, and we multiply this 20 by 120 by 1, and f of 1 minus 1 becomes 0, uh, which is a factorial of 0 is in fact 1. So we multiply this 120 by this one, so the result is 120. So the factorial of 5 is then 120. We are going to see this example practically in C++, so don't you worry about it. But there are two types of recursion. We have a direct recursion. uh, when a function calls itself, it is called a direct recursion. The example we have seen above is a direct recursion example. So we are going to first see what is direct recursion, and then we are going to see practically what is indirect recursion. When a function calls another function and that function calls the calling function, then this is called indirect recursion. So for example, function A calls function B and function B calls function A. So this is called a indirect recursion. So to see the practical example of both direct recursion and indirect recursion, so let me create a new project in code blocks. So first we are going to discuss direct recursion. So I'm going to say direct recursion. Click next, click finish. So we have this auto generated code. I'm going to delete this line, and then I'm going to start writing, declaring a num variable, and then we are going to prompt the user to enter a number, and then we are going to see c in num, and then we are going to display factorial of entered number, which is f of num. So we are calling a function. So we haven't defined this function yet, but I'm going to define it at the top. So what is f of n? F of n is a function that returns integer value f of, and that also accept an integer value. And then um, we can write here uh, this is called the base condition. It is very important to specify the base condition in recursion. Otherwise, your program will throw stack overflow error. Okay, so these are just comments for you, but like what is a base condition? So we are fine here. We are like, what is the objective of this program? We are going to finding a factorial of a number. So how do we find a factorial of a number? So first, when n is less than, or this is our base condition, or equal to 1, then we are going to say return 1. Otherwise, I'm going to go to the else part. Else return n factorial f of n minus 1. So what is happening here? We are again calling this f of n inside of the f of n function. So this is called a direct recursion because we are directly calling this f of n within this function. Alright, so return f of n multiplied by f of n minus 1. So I think that's it. So let me scroll down. Let me get some space. So we have, okay, let me compile it. And there is no error. So let us find the factorial of 5 and it is 20. So how does it do it? So we first enter a number, the number is 5. Factorial of entered number is we call that function, and then that function call itself again and again until we have a base condition where n is equal to or less than 1. So at that point we are going to return 1, and then the rest of numbers will be multiplied, like 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, and the final result will be displayed over here, where at the point where you have called the function. So that is what a direct recursion means. So here I'm just going to uh, uh, I'm just going to explain something like why is that we are calling it a direct recursion. So for example, when first we called that function, so the n was 5, and then what were we doing? N multiplied by f of 5 minus 1. So this f function is called once again. So we stop here, and what we do, f, in fact this is how execution happens. So this f of 5 minus 1 returns 4. So once again we are calling that function, so it will return 5 multiplied by 4. So once again we have called that function multiply by f of 4 minus 1. So which becomes 5 multiplied by 4 multiplied by 3 multiplied by, so once again we are calling that function, and here we have 3 minus 1. So once again we still have to call a function because we haven't reached the base condition. So f multiplied by 4 multiplied by 3 multiplied by f of 3 minus 1 is f of 2, and f of 2 is in fact we are calling that function, so 2 multiplied by f of 2 minus 1, which is 1. So at this point base condition is met and the value of 1 is returned. So 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, and this will be your answer. So once again let me run it. So enter the number, you can enter any number, so the result is 120. So here I can write that the final result is 120. Okay, let me save it. So this is how direct recursion works. So once again let me recall, when a function calls itself, it is called direct recursion. So the example which we saw here, so we define this function, this is called a recursive function. Why? Because inside of this function, in this statement, it is called by itself. Like f of n, we are calling the same function. So that is why it is called a direct recursion. Here we have declared a number, and then we prompt the user to enter that number, and then we displayed some text, and we call that function. And where the factorial of number was determined. So I'll see you in the next part of this lecture. So till then, take